Hello everyone, this video is presented by Walchand College of Engineering Sangli by the club ELISA, that's Electronics Engineering Students Association. The topic of this video is on digital electronics and particularly we'll be talking about flip-flop, and I am the facilitator Ms. Supriya Vijay Sawan. So let's begin with our video. This video will be having introduction to flip-flop, considering the combinational and sequential circuit, difference between latch and a flip-flop, identification of active low and active high state, and we'll be also talking about SR flip-flop. So let's begin. Firstly, let's clarify some basic concepts. This is a diagram of a combinational circuit. It has several inputs and several outputs. That is, it has n number of inputs and n number of outputs. It is a combinational circuit. But flip-flop is not a combinational circuit, it's a sequential circuit. Now, what's the sequential circuit? The sequential circuit has a memory element attached to the circuit. Output depends on input as well as the memory element. This is the difference between combinational and sequential circuit. And let me remind you again, flip-flop is a sequential circuit. It has two outputs which are complement to each other. Now let's have a look to the difference between latch and a flip-flop. So the circuit here is an SR latch. It has no control input. S and R can be changed accidentally or intentionally. So we need to attach a control input so that we can change S and R so that we get output until we have to save it. Therefore, we use a NAND gate and attach its output to S and R inputs. There is a common input to the NAND gate, and we also have the other inputs, like in this case S and R to the NAND gate. There is the only thing which will decide whether the circuit will act as a flip-flop or a latch is this control input. So this is a control input and this is the SR latch itself. Now here, enable means it is a level triggered. If this control input is enabled, whenever it's high, the latch will operate. The circuit is not operational when the enable is low. This circuit will act as a flip-flop when we replace enable by a clock. The circuit is not operation. This circuit will act as a flip-flop when we have a clock in place of enable. It will be flip-flop only when there will be edge triggering. Now what is edge triggering? When the clock goes from high to low or low to high, during this period the circuit is operational. Hence, latch is level sensitive and it checks input when enabled. Whereas in case of flip-flop, we checks input and is operational only when clock changes from high to low and low to high. Now let us go to our next slide to identify the active high state and active low state, which is a small but very crucial part for the learning the flip-flop. Now as you can see a circuit here, it has got a bubble at its output, and this is another circuit which has a bubble in its input. The outputs may differ from the inputs by virtue of location of bubble. When output has a bubble, we say that this is an active low state, and when an input do not, as in case here, do not have a bubble, we say that it's an active high state. Now let's consider the another case. Here the input has got the bubble. This means that this is in the active low state, whereas the output doesn't have a bubble, so it's in the active high state. So people, there are total 4 types of flip-flops: SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. Now we'll be going through the SR flip-flop. Now SR flip-flop is a combination of SR latch fit to a NAND gate. So this is a SR latch which is fit to a NAND gate. When a clock pulses are down or whatever may be the feedback, the output is always the previous state. Let's see the first condition. When S and R are 0, then here the output is 1 and 1 respectively. Then for SR latch, it is always equal, the output is always equal to the previous state. When S is 0 and R is 1, the output is 1 and 0 respectively, and so the output is 0 and 1. When S and R is 1 and 0, when S is 1 and R is 0, the output is 0 and 1 respectively. Then the output of SR latch is 1 and 0. When S is equal to 1 and R is equal to 1, then the output is here is 0 and here is also 0 respectively. Therefore, the output of SR latch in this case is not accessible state. 0 and 1 is called set state and 1 and 0 is called reset state. One drawback of SR latch is corrected in JK flip-flop. That is, whenever we get a set signal as output, and the same with the reset. But it has one drawback, that is, it has one non-accessible state which is then corrected by JK flip-flop. So this was all about the part of flip-flop. Please do like, share and subscribe our channel. Thank you.